Welcome to Section 16, finding the area or p-value and or endpoints using a graphing calculator. So it says that your graphing calculator can be found to use p-values and endpoints both. P-value being the designated area under a curve from some given point in some direction or between 2 points. And the endpoint itself is the cutoff place where that area stops. First foremost is that a graphing calculator will find a p-value or an area given an endpoint if we use the function which is second var's distribution, and if we go down to the number 2 option, normal CDF. So our normal CDF function is what we'll use when we were finding area. Now it's important to realize that different calculators are going to have a different screen, and the one I'm going to show is a TI-84CE, and yours may be slightly different. So if it's not exactly the same, you may have to contact me or do some investigation on how to get your calculator into the same mode. But all of my directions and our course revolves around a TI-70, or excuse me, a TI-84. It also goes on to tell us that in this function, that a normal CDF has 4 specific pieces to it. And those 4 specific pieces are lower boundary, cutoff point, upper boundary, cutoff point, mu, and the standard deviation of the function. Those commands must be in that order. Most newer calculators have a nice widget that opens up when we do this, and I'll show that to you here in a moment. Let's say that we're not finding actual area, but we're finding the actual endpoints because we're given area. Okay, well, now instead of using the same, we're going to use second vars still, and we're going to go to number 3, which is the inverse norm. Now, the inverse norm has a different set of parameters. To calculate inverse norm, which is looking for an endpoint given an area, the first enter will be the area below the cutoff. Now, that's for most older calculators, and newer calculators will find area between and area to the right. Again, if your calculator won't do what I am doing, then you may have to contact me. The mu value, comma, the standard deviation. So let's put this into practice and let's make this happen. So it says for a right or left tail test, we need to use an infinity of a lower and upper boundary. So if I look at these 2 particular items, if I'm using a left tail test, remember these numbers continually go to the left as far as we can imagine. So when we use a number to the left, we want something really, really far to the left. We are going to utilize the number on a left tail test, -1 times 10 to the 99. That is a very small number. It's a -1 multiplied by 10, 99 different times. If we have a right tail test, we're going to use a +1 times 10 to the E99 or times 1099. Okay, these are just so that we get an extreme number to the right or an extreme number to the left. We could probably put in 1,000,000 and be okay, but we want to get as close to infinity as possible. And these numbers will get us to infinitely many numbers above or below. So let's do our student exercises, and I will lay these out with the calculator, and I'm going to show you the actual calculator. So the first thing I'm going to do is I'm going to draw what's going to happen. And after I draw what's going to happen, then I'm going to switch over to my graphing calculator, and I'm going to show you what's going on. So I should be able to do a pretty good job of this. So we want the area below an 80 if the normal curve at 100 deviates by 20. So the first thing we're going to do is we're going to draw in our normal curve again at 100. We know that it's going up by 20 because it says that in the problem. And it's also going down by 20 because that's its standard deviation. We are looking for the area below the 80. Below 80. So in the last chapter, we shaded. Now what we want is we add an actual p-value for this particular item. So where we're heading to, we have 2 different numbers here that we're looking at. We have 2 cut points. One, we have a lower number, which is -1 E99. Little tiny number way out here, if you can imagine this number line continuing forever. And we have another number, which is 80. This is going to be our upper, and this is going to be our lower. The 100 is going to be our mu, and the standard deviation of 20 is going to be our deviation in and out. So we're going to put these into the calculator so that we can utilize them. So I'm going to switch over to my calculator. And the first thing I'm going to do is I'm going to clear everything. So I'm going to clear. And remember that what we're looking for is we're looking for the second button and the vars button, which is the distribution. Okay, second vars. We're going down to find area. When we're finding area, we're looking at number 2. So you can either arrow down or you can push number 2. Now, remember what I just told you a second ago. What is your lower number? Well, my lower number is -1 E99. I'm going to clear that so you can see my keystrokes. On my calculator, if you look, the red keys are what I'm pushing. So the first thing I'll push is a -1. And then I can do either times 10, or I can use my E key right here, my EE above my comma. Second E, and then I'm going to push in 99. That is a really, 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 really small number. -1, 99 times 10 to the 99 to the left. My upper number, I'm going to scoot down. My upper number was 80. So I'll put in an 80. My standard deviation, the middle of my problem, was 100. Or excuse me, my mu. And my standard deviation, or my movement away from the middle, was in 20. We know that because we were normally distributed on a 100, 20. I'm going to scoot down to where it says paste. I'm going to hit the enter button. This is the code that it's written in what it's saying. So if I have a calculator that didn't have that widget that I just opened up, and it just opens up the word normal CDF, you need to type -1 E99, comma, 80, comma, 100, comma, 20. Low cut point, high cut point. This is the center or the mu, and this is the standard deviation. Hit the enter button, and you get 0.158, or approximately 0.16. If I go back to this, that means that I have now calculated the p-value to be 0.16, which is about 16%. Let's go to the next one. So first of all, I'm not going to put all my numbers in, but we want the area above a 70 on a 120. So again, 100. And we know that we're on 100 or we're on a 20, so I'm going to go up to 140. And I know I'm going downwards, so 80 and 60. I know that I want to have the area above 70, so this might be a little tricky for some of you depending on your calculator. So first of all, I want the area above 70, so I'm going to mark out 70 about right here, and I want the area above. Some older graphing calculators only measure below. Some graphing calculators will measure above. So I'm going to have to do this in 2 steps, and then you're going to have to decide who you are. So I'm going to do it in old style. If you have an old style calculator that doesn't give you an option for left and for right, we're going to have to follow old method. And then I'm also going to calculate it in new. New style being my calculator will calculate left and right. So the first one I'm going to do is I'm going to do the new style because that's how my calculator is set up. I'm going to go to my calculator and I'm going to clear my screen. I'm going to go to second vars. I'm going to choose number 2 for my normal CDF. I'm going to pretend that my calculator understands left and right because it does. So my lower number, remember, the smallest number I had, I wanted the area above a 70. So my number is 70. My upper number is big, really big. How big? 1 E99. Not negative, but positive this time. Really, really far to the right. I'm still on a 100 and I'm still on a 20. I'm calculating the area to the right-hand side, starting at a 70 and going to infinitely big if I have 100 in the middle and I'm deviating by 20 places. If I hit that button, I'm going to get approximately 0.93. So I'm going to go to the board and I'm going to write that one, 0.93. So in mine here, I just did a normal CDF. My low number was 70. My high number was 1E99. My mu value was 100. And my standard deviation was a 20. And I got approximately a 93% p-value percentage. Now, okay, so what do old calculators do? Well, old calculators won't do that. Old calculators say you have to find this area here, and then you have to take 1 minus the left area because they will only calculate left area. And that's okay, I can do that. It's not a big deal. Now what I'm going to do when I do my normal CDF is I'm going to invert a couple things. First of all, my low number is going to be negative 1E99. It's actually out here somewhere. I'm finding the area I don't want. Comma, oops, I got to make some of this stuff go away. Comma, I'm going to work my way up to that 70 number. I'm still going to have the same 100, and I'm still going to have the same 20. I'm going to show you what that looks like when we do that on the calculator, because it's not going to say 93 when we get an answer, but we'll see how it is really 93. So I go to here, and I go to second, and I go to my normal CDF, pick number 2. So again, remember, I'm going to go negative 1. I'm going to use my second function, e, 99, and get this really crazy tiny number. I'm going to work my way up to a 70. I'm going to keep my mu. I'm going to keep my standard deviation. I'm going to hit my paste, and I'm going to hit my buttons, and notice what it says, 0.066 or 0.07. So when I go back to here, it says, hey, your p-value is 0.07. Well, remember, though, what it was really calculating for me was the left-hand area, and I don't want the left. I want the right. So I need to take 1 minus 0.07, and you got it. That's 0.93. Are there some more steps? You bet there are. Do you have a better understanding of it? I think you actually might. If your calculator calculates a new, good for you. If your calculator calculates an old style, well, I just showed you how to do it just fine. So let's go to our next one. So what is the area between a 0.7 and a 0.24? All right, well, I'm gonna write these out, and I'm gonna write how that will go into the formula and how that will affect us. So first of all, the area between. Now, notice that it's a standard normal. A standard normal is on a 0, 1, always. If you see the word standard and normal, you know that your center is 0 and your standard deviation is 1. I want to be between a 0.7, which is somewhere about here, and a 2.4, which is somewhere about here. Well, those are my high and low numbers. So I'm going to do a normal CDF function. I'm going to pick my low number to be 0.7. I'm going to pick my high number to be 2.4. I'm going to center that on a 0, and I'm going to tell it to standard deviate by 1. Now, it is true that calculators automatically will calculate 0 and 1 if you don't insert it, but I kind of like to be sure of this when I do it. The anal retentiveness in me, if you will. So I'm going to go to my vars, choose number 2. My low number this time is 0.7. My high number is 2.4. My standard deviation this time and my mu value are 0 and 1. I hit my buttons, I calculate, I paste, and I have approximately 0.23, 23%, whatever you want to call it, but we report p-values as decimal values, as in 0.23. It says round your answer to 2 decimals. It didn't say to return it as a percentage, so I'm not doing that. My send point 1 now. Now, Exercise number 4 is different, and I need to scroll down so we can see the difference here. Exercise number 4 is not asking me for a percentage. You should notice right away that exercise number 4 says, what is the end point Z? Okay, well, it's not an area. It's going to give me the area. So I have to find that. So it says, hey, what's the area to the left of Z 0.12? Okay, so first of all, what's that look like? Remember, standard normal, 0, 1, 2, -1, -2. We are going area to the left, it says it in the problem, of 0, 1, 2. So 0, 1, 2 is pretty tight here, and we're going left. Left is good because all calculators understand left area. So now, this is not a normal CDF. This is that second formula, which is an inverse norm calculation. So I'm going to open up an inverse norm calculation on my calculator and show you how to enter it. We also have to notice that that area is being told to me to be 12%. So go to my calculator, second vars. This time we're going to scoot down to number 3, inverse norm. We want to find endpoints, inverse norm. We're going to calculate the area. If you have an older calculator, it's always area to the left. If you have a newer calculator, well, guess what? Left, center, and right. Nice feature for a new calculator, but if you're on an older calculator, it's always left. So I'm going to put in the area, not 12%, the decimal, which is 0.12. My mu value was definitely a 0 because this is a standard normal. My standard deviation is a 1. I know it's a left. I'm going to hit paste. I'm going to calculate, and I get approximately negative 1.17. What did I just find? I just found the endpoint of Z, which is approximately negative 0.17. Z equals negative, I just lost what that number was, sorry. Negative 1.17. So now that area I was calculating in blue, I can now adjust it to fit properly because what I have up there was just simply, okay, it's to the left of something. I now know that, and let me get rid of all my stuff here, that it should start at approximately negative 1.17, which is about right here, and this will account for approximately a p-value of 0.12. The other one was just an initial arbitrary to show I'm going left of something. Let's go down to the bottom one, exercise 5. What is the endpoint? So again, we're going to use an inverse norm here, and I know that as soon as I see endpoint, I know it's inverse norm. In a standard normal distribution, so again, I have a standard normal. If it's the area to the right, okay, area to the right, okay, old calculator, you're going to have to do something different. New calculator, not so much. And it's to the right of a Z is 0.63, so that my p-value is 0.63. There's some things we can say about that, but we're going to wait a second. So I have a 0, I have a 1, I have a 2, I have a negative 1, and I have a negative 2. So let's go to our calculator and let's calculate it using new style stuff here. So I go to second, I go to vars, I go to number 3, inverse norm. My area this time is approximately 0.63. 0.63. I'm on a standard normal, so I'm 0, I am 1, but I have, remember it said area to the right. All right, so I'm gonna cheat because I got a cool new calculator. I'm gonna say area to the right. I'm gonna come down here. I'm gonna hit the button, and boom, I get approximately a negative 0.33. A negative 0.33 for my z-score. So my z, because remember, I was looking for an answer. Z is approximately negative 0.033, and I think it was a 2 without going back to the screen. Now remember, I used a function in order to calculate the area to the right. So I told it area to the right of z. All right, well, what if I don't have a cool calculator and I have to do it the older method? Okay, well, if the area to the right is 0.63, then the area to the left is 1 minus 0.63. It's the other part, okay? So if this is 63%, this is 1 minus 63%, or 100 minus 63%, okay? So the thinking here is, okay, what if I can only calculate left? Okay, well, we still have to be able to get this negative 332. Back to the calculator. Second, inverse, number 3. Now I'm going to do area to left. Now notice what I'm going to do. I'm going to do parenthesis 1 minus 0.63. I'm going to let the calculator figure out for me that decimal value to the left. I'm going to leave it on mu 1, and I'm going to put it back to left. So now it's left only. I'm going to hit the button. I'm going to do the calculations, and voila, look at what I get. Exactly the same answer. So no matter how I work this out, whether I'm using older technology or newer technology, I am calculating the endpoint z of negative 0.331, which will give me an area of approximately 63% to the right.